let's begin. All right. So number 1 says matter. Matter is anything that takes up mass or volume, which is C. An element is going to be the simplest form of a matter, which is E. A compound is 2 or more elements combined, which is B. A homogeneous mixture is 2 or more types physically combined, and they look uniform. They look the same. And then heterogeneous is they look different. Okay. Any questions on that? Okay, moving on. Number 2 says classify the following as an element, E, compound C, homogeneous, HOM, or heterogeneous, or not matter at all. Okay, here we go. So water. Water is H2O, so that is known as a compound. Iron is an element. Light. What would light be? Yeah, it's one of my trick ones. It's not matter. All right, so not matter is NM. Trail mix. Trail mix is heterogeneous, HET. Helium is an element. A metal alloy, that's a mixture of metals. All right, an alloy is a mixture of metals. So that's actually going to be a compound because there's a lot of different metals put together. Okay. Salt is another compound. Soil has a lot of dirt, rocks, water, roots. So that's going to be a heterogeneous mixture. All right. Gravity. Oh, gravity. I don't know the rest of the words, but that is not matter. All right. Air. Air has so much in it. There's so many elements. There's so many material that we can't even see, but it's a big mixture. And I can't see like different parts of the air. So that's homogeneous mixture. What about sugar? That is a compound. And sodium is an element. Any question on number 2? All right, moving on. A new number 1. Match the 6 phases to the correct spot. Okay, melting is 5. Condensation is a gas to a liquid, so that's 4. Sublimation is solid to a gas, which is 1. Freezing is a liquid to a solid, which is 6. Deposition is a gas to a solid, which is 2. And then evaporation is from a liquid to a gas, and that is 3. Okay. Then I already circle the 3x, endothermic. So endothermic is it absorbs heat. So it absorbs heat, or it feels cool. It's getting colder. All right. All right. Where exothermic feels hot. Does that make sense? Any questions? All right. Final section. Label the following points and phases on the heating curve. Melting point. So this dash is the melting point. Okay, that's where the melting point is. Up here is the boiling point on that dash. Okay. Solid is this upward line right there. That's your solid. This is your liquid. This is your gas. Okay. Now, solid and liquid, well, it's going to be the line between the solid and liquid. So it's this flat line, solid dash liquid. And the same for the liquid and gas. It's going to be that line. Any questions on that? You feeling good? Okay. All right. Physical, chemical changes. Now, some of these might be both. Some of them might be both. All right. Let me scroll that down a little bit. All right. Melting tin. That is definitely physical. Salt dissolving in water, becoming salt water. That can be chemical or it can be physical. So whatever you put, I'd count it correct. A bike rusting. Rusting is chemical. Burning a cake. That is also chemical or physical. That can be either one, whatever you put. Freezing water is physical. Roasting marshmallows. That is also physical. And splitting wood is physical. Okay. Bond types. What type of elements are present in ionic bonds? Okay, in ionic, you have at least one metal and a nonmetal. Okay. Explain what happens to the valence electrons. All you have to say is they transfer or one gives up an electron to the other person. Either way works. All right. Number 2 says, what type of elements are present in a covalent bond? Those are 2 or more nonmetals. And what they do is they share electrons. Does that make sense? Am I going too fast or are we good? Good? 3 says, identify the following properties as ionic or covalent. Now, what I like to think of is ionic is salt. Salt is ionic. The sugar can represent covalent. That's what I always like to imagine because we did that lab, right? All right, so always soluble in water. Well, the salt was soluble in water. Okay. Solid crystals. All right, so both of them were solid, but the ionic is a solid crystal. Non-conductive. Ooh, which one was non-conductive? Did salt or sugar? Sugar. So non-conductive would be C. What occurs between a metal and a non-metal? Well, we just answered that above. That's ionic. Which one shares electrons? Well, we just answered that. That's covalent. Conductive. Oh, we just said ionic is conductive. Transfer of electrons. Ooh, we just said that's ionic. Okay. Low melting points. Which one melted? Sugar or salt? Sugar. So sugar or covalent. And then which one is non-metals? Only non-metals? That's covalent. Any questions on those? We're going to keep going. Would the following pairs be ionic or covalent? So ionic at least has a metal. So what I'm looking to see is there a metal or not? Hydrogen and carbon, is there a metal? No. Covalent. Lithium and sulfur, is there a metal? Yes, lithium is a metal, so that is ionic. Calcium and oxygen? Yes. Calcium's a metal, so that's ionic. Nitrogen and chlorine? No. There is not a metal. Phosphorus and bromine? No. Not again. Beryllium and fluorine? Yes. There is a metal. Beryllium is metal, ionic. Any questions on that section? We all good? Yeah. Final one. All right. Names and formula. Which type requires prefixes? The prefixes are only covalent. Only covalent, okay? List the 10 prefixes. You got mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Oop, there we go. All right, those are the 10 prefixes. Okay. Which type of compounds requires a neutral formula? Well, that's ionic. That's the other one. What trick can be used to determine the neutral formula? Yeah. Crisscross. The crisscross. That's what I'm talking about. Crisscross, right? All right. Any questions on that section? Feeling good? All right. What charge is associated with the following groups or elements? Well, if you have your periodic table, this was pretty easy. Group 1 had a +1. Group 2 has a +2. Group 17 has a -1. Oxygen has a -2. We good there? Last is naming. Okay. Now, here we go. The first thing I'm going to determine is if it is ionic or covalent first. So ionics have metal. So is Na or Cl a metal? Yes, so the first one's going to be ionic. Is potassium or fluorine a metal? Well, potassium is, so the second one's going to be ionic. Phosphorus or bromine? No, so that's going to be covalent. N or H? Neither one's a metal, so that's covalent. Calcium or oxygen? Calcium's a metal, so that's ionic. Magnesium or chlorine? Magnesium's a metal. Carbon or sulfur? Neither one, so that's covalent. And then potassium and oxygen. Potassium is. So the final one is ionic. Oh, you can't see that. Let me move this little thing here. There we go. All right. So whatever you feel more comfortable naming with, let's do that one first. All right. I'm just going to choose ionic because I have ionic first. So I have Na and Cl. So the first, all the metals, I just put its name. So Na is sodium. So I just put sodium. Now the non-metal is chlorine. However, I can't say chlorine. I have to say chloride. All right, so I have another ionic, but this time I'm given the name. I'm given potassium fluoride. So what I'm going to do is I got to find potassium on the periodic table, which is K. What charge does K have in the first column? 1. Let's see, F. What charge does F have? -1. When you crisscross, how many of each do you have? 1. So your answer is KF. Okay, your answer was KF. All right, I'm going to skip the next two because those are covalent. I'm going to go to calcium oxide. Calcium oxide. All right, I skipped a few. Calcium oxide, Ca. What charge does Ca have? 2. Oxide. 2. -2. When you crisscross, how many of each do you have? Okay, so I have Ca2, O2. I skipped a few, if you can see. All right, next one's ionic. Let's do ionic. Magnesium chloride, Mg, and Cl. What's magnesium's charge? +2. Chlorine? Let's crisscross. So I have 1 Mg, 2 Cls. So I'm going to have Mg1Cl2. And then the last ionic down here, I have potassium. And instead of oxygen, what should I say? Oxide. Okay, we're almost done. Almost done. All right, so now I'm going to take off my ionic thinking cap, put it to the side, take on my covalent thinking cap, put it on. Prefixes. Got to think prefixes now. Covalent. Phosphorus pentabromide. So phosphorus, how many phosphorus do I have if there's no prefix? 1. So 1 phosphorus. Pentabromide. What's penta? 5. So it is PBr5. Okay. Next one down is N2H4. Well, let's do N2 first. What's my prefix for 2? So I have dinitrogen. What's my prefix for 4? Tetra. That's tricky. Tetra. And it's high. Instead of hydrogen, it's going to be hydride. I'm running out of space. I'm running out of space. Hydride. Last but not least, I have carbon and sulfur. I have 1 carbon. What's the prefix for 1? Mono. Do I put it in front of carbon? No. I do not put mono in front of carbon. But I can put mono in front of sulfur, right? But instead of sulfur, it's going to turn into sulfide. There it is. Now, tomorrow,